Hello, everybody. On this exciting episode of Math 9, Equalities and Solving Equations, we're going to solve equations that have fractions. And we've already kind of done a little bit of that on, I think it was 6.2. We did some fractions, but these questions are all going to be fractions. We're going to talk about how to deal with fractions, and we're also going to talk about having multiple fractions, because that's also going to happen on this one. We'll start off with a nice basic one. So if you're looking here, the question says solve. So to solve means you want to get the letter by itself. The first thing that I recognize is that I have fractions. And honestly, if you're like me, you probably hate fractions, right? I don't like fractions, and I talk about getting rid of fractions all the time in Math 10, Math 20, Math 30. You're going to hear me say fractions are the worst. Get rid of the fractions. It'll make everything easier. For a basic question like this, where there's only one fraction, the way that you get rid of that fraction is by taking whatever's in the denominator and multiplying everything by that denominator. So for us, our denominator is n. So I'm going to multiply everything by n. And what happens is wherever the fraction was, in our case, it was this 18 divided by n, those n's end up canceling out, and you're left with only the 18. You're not left with 18n because the n's canceled out when you multiplied and divided both of those things by n. On the right-hand side, we have 2 times n. We just write that as 2n. Now you have a question with no fractions. These are super easy to solve. We just have to get the letter by itself. We do that by getting rid of that 2. So we have to divide both sides by 2, giving me a final answer of 9 equals n. So it's not that bad, right? You just find out what's on the bottom. You multiply everything by that letter or number. So if you look at B, we have the same problem. We have a fraction. We want to get rid of that fraction. So whatever's on the bottom, we're going to multiply everything by that. So we're going to multiply this 36 by n and this negative 12 by n. And wherever your fraction was, when I have n times 36 divided by n, the n's end up canceling each other out, and all I'm left with is 36. Right? The reason being is you're multiplying and dividing by the same thing. On the right-hand side, we just have negative 12n. Wonderful. To solve that, we have to get rid of the negative 12n. That's technically negative 12 times n, because there's nothing in between the 12 and the n. So the opposite of timesing is dividing. We divide both sides by negative 12. That gives me an answer of negative 3 equals n. Beautiful. Let's move on to C. C is a little bit trickier. So if you look at C, we actually have 2 fractions now. The way that we're going to get rid of these fractions is by multiplying by both denominators. So in this case, my first denominator is n, so I'm going to multiply both sides by n. My second denominator is 7, so I'm going to multiply both sides by 7. Now here's what ends up happening. On the left fraction, I have 7 times n times 56 divided by n. On the right-hand side, I have 40 times n times 7 divided by 7. If we look at each of these fractions individually, so I'm going to look at the first fraction, the green one, I notice that I have an n on the top being multiplied and an n on the bottom being multiplied. And because they're both being multiplied, all the things on top being multiplied, I can cancel those n's out, which means I now have 7 times 56 on the right-hand side. Sorry, on the left-hand side. On the red side, or the right-hand side, I notice that I have a 7 on the top and a 7 on the bottom. So those are also going to cancel out, now leaving me with just 40n. And what we've done is we've successfully gotten rid of the fractions. I'm going to do that in like a faster way in the future, but I want you to see an example where we go nice and slow and we see how things cancel out so that we end up with no more denominators. Perfect. On the left-hand side, 7 times 56 is 392. On the right-hand side, we still have 40n. To solve for this, I need to divide both sides by 40. If you do that, I think you're going to get a decimal. Yeah, you get 9.8 equals n. And that would be your solution. Awesome. So when we have multiple fractions, we multiply by both things that are on the bottom. D. So if we have D, I notice I have two fractions. I have n and I have 13. So I'm going to multiply both sides by n. So I have n times 42, and I have 28 times n. And I'm also going to times both things by 13. When I go to rewrite this out, I'm going to just recognize these n's would cancel on the left, these 13's would cancel on the right. And I now have, on the left-hand side, 13 times 42 equals negative 28n. I then can calculate the right-hand side. 13 times 42 is 546. On the right-hand side, I have negative 28n. I want to get n by itself, so I have to divide negative 28 to both sides. When I do that, I end up getting 19.5, and it's negative 19.5. So that's my final answer. Just a reminder, it's been a while since I've talked about it. As you're doing equations in algebra, that's what this is, right? We're solving equations using algebra. It's important that you keep your work organized. So I'm writing a reasonable size, not too big, not too small. I'm always working straight down whenever possible, so things are taking like a logical flow and I can see every step. And after I do something, I always reorganize my work. So I show what I did and then I rewrite everything out. I show what I did and I rewrite everything out. These questions are only going to get bigger and harder as time goes on in math. You need to be organized. Okay, let's look at example 2. So now we have three fractions. We could do our trick, which is like multiply by everything you see on the bottom. But because there's only numbers on the bottom, I'm going to show you another trick. I'm going to look and notice what my numbers on the bottom are. I have 3, I have 6, and I have 3. I can get rid of all the numbers in the denominator if I can find a number that they all could divide into. So for instance, like 3 could divide into 3 to be 1. But 3 divided by 6 would not equal a whole number. So that multiplying everything by 3 wouldn't work. If I tried multiplying everything by 6, 6 divided by 3 would be 2. 6 divided by 6 would be 1. So 6 would actually work. This means 6 is the number that I want to multiply everything by. It's called doing the lowest common multiple. You maybe have heard of saying things like get a common denominator, same kind of idea. So if you look at the denominator and you ask yourself, like, what number could those all become? They could all multiply by 6. If you multiply everything by 6, this is what you get. You get 6 times n over 3. That's my first fraction. Plus 7 times 6 over 6 equals 2 times 6 over 3. So you'll notice I'm just rewriting my equation after I multiplied everything by 6. Now, if we look at each fraction, we can look at the numbers and figure out what happens with those coefficients. So for instance, 6 divided by 3 equals 2. And the n is still there. Plus, if I look at the second fraction, I notice these 6's actually cancel out, leaving me with just plus 7. Equals. If I look at this, 6 divided by 3 would equal 2, That means I now have 2 times 2 on the right side. Meaning I have 2n plus 7 equals 4. That's kind of a long way of showing what happens when I times everything by 6, but hopefully it just shows you that, hey, the denominators all will go away because my denominators could all divide into 6. At that point, you just have to solve it. So to solve it, you have to get n by itself. We do that by subtracting 7 from both sides. That gives me 2n equals negative 3. Divide both sides by 2. And I end up with n equals negative 1.5. And that's our answer. Remember, stay organized, right? I show my work, and then I rewrite things out, and I show my work, and I rewrite things out, and so on and so forth. Okay, let's look at B. So B has 3 fractions again. All numbers. So I have a 4, a 5, and a 10. My goal is to find a number that all of those could divide into. So for instance, the number 10 could divide into 10, 5 could divide into 10, but 4 could not divide into 10. So 10 would not work to multiply things. A number that would work is 20, because 20 divided by 4 equals 5, 20 divided by 5 equals 4, and 20 divided by 10 equals 2. So I could multiply everything by 20, and it would get rid of all my denominators. We'll do that right now. So we'll go to each one of our fractions, and we're going to multiply by 20. So I now have 20n over 4 plus 1 times 20 is 20 over 5 equals 7 times 20. I'm just going to actually write that as 7 times 20 still over 10. You could multiply the 7 times 20 to become 140 and then divide 140 by 10, but I'm just going to leave it like that so that people realize that this 20 is what's getting rid of everything. On the left fraction, 20 divided by 4 becomes 5, and the n is still there, plus 20 divided by 5 is 4, equals, on the right-hand side, 20 divided by 10 would equal 2. 7 times 2 is 14. All right, so I have this 7 times 2 from my 20 divided by 10. And then all I have to do is solve this. To solve, we've done multiple lessons of this, so if you're still struggling with that, you can go back and practice and maybe watch those videos because I go a little slower. I'm going to subtract 4 from both sides. Gives me 5n equals 10. I'm going to divide both sides by 5. Giving me n equals 2. Beautiful. Fractions. Get rid of them by finding something they all could multiply to become. We got a couple examples here left. We'll look at C first. So looking at C, I have denominators of 5 and 2. So I want to multiply by 5 and multiply by 2. Or I want to multiply by something they both can divide into. The other thing I'm going to do is when I look at that n minus 1 in the numerator, I'm going to put invisible brackets around it. Just because I want to remember that's a binomial, like that's a thing together. Awesome. Now, if I wanted to get rid of the 5 and get rid of the 2 in the denominators, I'd have to find a number they both can divide into. They both can divide into 10. So that's what I'm going to multiply both sides by. This would give me 10 times the numerator of n minus 1 over 5 equals 3 times 10 over 2. In the first fraction, I can then look at these two things and realize 10 divided by 5 is 2, and then I still have my numerator of n minus 1 like that. Equaling, on the right-hand side, I'm going to notice that 10 divided by 2 is 5. So on the right-hand side, I have 3 times 5. And what I've done is I've successfully gotten rid of my denominators. This now just becomes a question that we've seen many times in previous lessons. So to deal with brackets, a reminder, the 2 has to come into the brackets. And that's why putting the brackets in this first step was so important, because people forget to multiply the 2 to both things on the top to make it 2n minus 2. On the right-hand side, 3 times 5 is 15. To solve this, we add 2 to both sides. That gives me 2n equals 17. Divide both sides by 2. N equals 8.5. Beautiful. Looking at D. The first thing I'm going to realize is that I want to put brackets around my numerator because I want that n minus 4 to be treated as one thing, as a binomial. I then have to find a number that 3 and 6 could both divide into. 3 and 6 could both divide into 6, so I'm going to multiply both sides by 6. That would give me 6n minus 4 divided by 3 equals negative 5 times 6 divided by 6. On the left-hand side, 6 divided by 3 becomes 2. N minus 4 is still in the brackets. On the right-hand side, the 6's are actually going to cancel, and I'm left with negative 5. I can solve this by multiplying the 2 into the brackets. This becomes 2n minus 8 equals negative 5. I'm going to add 8 to both sides. That gives me 2n equals 3. And I'm going to divide both sides by 2, giving me n equals 1.5. So you see these questions are getting bigger, right? Show your work, rewrite. Do something, rewrite. Do something, rewrite. And work in a nice, straight fashion whenever possible. Don't go all over your page. Don't try to do more than one thing at a time. Right? Do one thing, reorganize. It is critical. All right, E. If I look at E, first thing I see that I have fractions, and I also see that I have binomials in my numerator. So I'm going to put brackets around everything. The next thing is I'm going to look at my numbers and be like, okay, I have 5 and 4. What's a number that 5 and 4 could both divide into? They both could divide into 20. So I times everything by 20. On the left-hand side, that means I have 20 times 2n minus 1 divided by 5. And on the right-hand side, I'm just going to rewrite it so the 20 is out front. But I have 20 times n minus 2 over 4. And then I can focus on my fractions and get rid of them. On the left-hand side, 20 divided by 5 would be 4. And then I would still have 2n minus 1 in those brackets. On the right-hand side, 20 divided by 4 is 5. And I still have n minus 2 on the right-hand side. Wonderful. At that point, I have a basic question where the fractions are all gone, so I need to multiply into my brackets. When I do that, on the left-hand side, 4 times 2 is going to be 8n, and then 4 times negative 1 becomes negative 4. On the right-hand side, 5 times n becomes 5n, 5 times negative 2 becomes negative 10. This is now a question that's straight out of lesson 6.3. So to solve this, I move the 5 n's from the right side to the left side. So all my n's are on one side, giving me 3n minus 4 equals negative 10. Then I'm going to add 4 to both sides, which gives me 3n equals negative 6. When I run out of space on a question, like I have right now, I just write a straight line down, and then I start a new column. So I was at 3n equals negative 6, like that, and then I start working again. So divide both sides by 3, gives me a final answer of n equals negative 2. Beautiful. Got rid of the denominators by multiplying by something that both denominators can get into. Look at F, we're going to do the same thing. So I'm going to put brackets around my binomials on the top. I'm going to multiply by something that 3 and 2 can both divide into. They both can divide into 6. So this gives me 6 times 4n minus 3 over 3 equals 6 times n plus 3 over 2. I then can focus on my monomials, my numbers out front. On the left hand, 6 divided by 3 is 2, 4n minus 3. On the right hand side, 6 divided by 2 is 3, and then n plus 3. To solve, I have to get rid of my brackets, so I'd multiply into the brackets to become 8n minus 6 equals 3n plus 9. This is now a 6.3 question because I've gotten rid of the brackets and I have letters on both sides. Whatever side has less letters, so the 3n, I decide to move to the other side by subtracting 3n. That would give me 5n minus 6 equals 9. I then have to add 6 to both sides. That gives me 5n equals 15. I'm going to start a new column with that, so I have 5n equals 15. And then I'm going to try to get rid of the 5 by dividing both sides by 5. That gives me n equals 3. And I'm done. Gorgeous. We have 2 questions left. Both are a little bit harder than anything we've seen, so we're going to talk about how to handle those. Okay, the reason these questions might look a little bit harder is because you have 2 fractions. So if you look at this one, I have a fraction there, I have a fraction there, and then I have a non-fraction right there. And sometimes that throws people off because like, I don't know what to do with that. Here's my strategy. My strategy is anything that's not a fraction, I'm going to turn into a fraction by saying it's divided by 1, right? There's always an invisible divide by 1 on any constant. We don't write it because if you took 5n and divided by 1, you'd have 5n still, right? You've just left it into one group. But by doing this, what it allows me to do is it allows me to treat these questions the same way I did the ones above. And I have to ask myself, what is a number that 4, 1, and 6 can all multiply into? And the answer is I could divide, or I could multiply all these numbers by 12 because 12 goes into each one of those. So I now have 12 times 3 divided by 4 minus 12 times 5n divided by 1 equals 12 times 67 divided by 6. And just like the previous questions, I can then focus in on my fractions and get rid of them. On the first fraction, 12 divided by 4 would be 3, and the other 3 is still there. On the middle fraction, 12 divided by 1 is still 12, so I still have 12 times 5n. And on the right-hand side, 12 divided by 6 is 2, and the 67 is still there. But you notice I turned something into a fraction just to like help remind me that there's a 1 there. And then I figure what numbers could they all go into, and I treat them the exact same way. Now that my fractions are all gone, I can do some calculations. So 3 times 3 would be 9 minus this in the red that I just underlined is 12 times 5 times n. So I can actually do the 12 times 5. And I can combine that to become 60n. Those can go together because it's multiplication, right? So constant or coefficients can multiply with other coefficients. 12 times 5 goes together. And then on the right-hand side, 2 times 67 should be 134. Beautiful. Now I just need to solve by getting n by itself. So I'm going to move the 9 over. I have to move it by minusing because there's an invisible plus in front of there. So the opposite of plus 9 would be minus 9. Those will cancel out. I have negative 60n equals 125. I then can divide both sides by negative 60. So if I have 125 and I divide by negative 60, I end up getting 2.083 repeated, which I'm going to write it like this. So n equals negative 2.083 repeated. That would round, it said to the nearest tenth, I believe, at the front of the page, and equals negative 2.1. And that's a rounded answer. Perfect. If you want, you could pause this video right now on H and try this question on your own and see if you can get it. Or you can just follow along with me. The first thing I do is I realize there's fractions and I want to get rid of those fractions. The second thing I realize is that this 1 has an invisible divide by 1. I want everything to have a fraction. That way I can just kind of treat every single term the same. Beautiful. I now look at the denominators. I have 2, 1, 4, and 4. I need to find a number that all those can divide into. Those can all divide into 4. So I'm going to multiply everything by 4. That gives me 4 times n over 2 minus 4 times 1 over 1 equals 4 times n over 4 plus 4 times 3 over 4. And then I'm going to go fraction to fraction, and I'm going to cancel my denominators. In the first fraction, I'm going to look at 4 divided by 2 and realize it's just 2. And the n is still there. In the second fraction, I'm going to realize that 4 divided by 1 is still 4, and then 4 times 1 is just 4. On the right-hand side, 4 divided by 4 will cancel, leave me with just the n. Plus, on the last fraction, 4 divided by 4 would cancel, leaving me just with the 3. Awesome. This isn't that bad of one to solve, especially once we've gotten rid of all of our fractions. So we're going to minus n to both sides, giving me n minus 4 equals 3. And then I'm going to add 4 to both sides, giving me n equals 7. And that's the final answer. I hope you enjoyed this thrilling math video and that you guys are staying sane and happy. And if you need anything, always reach out and let us know. Stay safe. Enjoy the rest of your day.